Alright, so now we're going to be looking at building our multiplying decimals understanding and starting to pull things together. So we're going to look at how what we've been doing with the powers of 10 actually relates to multiplying decimals. Before we start though, I want you to pause the video and look at the three numbers I have on the screen. And I want you to think about what can we do using multiplication to make all three of the numbers whole. What could we do? So hopefully you started to think about what we were doing with our powers of 10. So for example here, since we had 37 and 5/10, I need to move my decimal point over one spot. So I know I could multiply it by 10 or 10 to the first. With 7 and 89/100, I'm going to move it two spots. So I'm going to multiply it by 10 to the second. And with 7 and 802,000, I'm moving it three spots. So I'm going to multiply it by 10 to the third, just to create whole numbers. So like this would be 375, this would be 789, and this would be 7,802. So now, what would we do if we were to go backwards and to start putting the decimal back in? So if I had 245 and I wanted to change it to 24 and 5/10, well, since we're moving backwards, we know we're going to do division. And here, it's one decimal point to the left, so this would be dividing by 10. 346, to change it to 3 and 46/100, I'm going to move it back two spots, so I'm going to divide by 10 to the second, or 100. Why don't you go ahead and pause the video and try the next two on your own and see how you are doing with this. Hopefully here you notice that I have to move it back three spots. I'm going to divide by 10 to the third. And on the next one, moving back two spots, we're going to divide by 10 to the second again. So to move decimals out of the way, we can multiply by powers of 10 like we did on the previous slide. And when we're putting it back in, we're going to do the inverse, or actually divide. So why is that important to understand? Well, when we start looking at multiplying decimals, that's actually what we're going to do. We're going to use our powers of 10 to create numbers that we are much more comfortable using. So for most of us, that means creating whole numbers. So here, for example, I have 1 and 4/10. I want to create a whole number to multiply. So I'm going to multiply this by 10 to the first power, because 1 and 4/10 times 10 to the fourth power, it's going to give me 14. And I'm just going to put the decimal point at the end to remember that I need to put it back in the end. So now, because I've since I have this and I have mathematically moved the decimal point out of the way, I can just go ahead and multiply my numbers like I would normally. 5 times 4 is 20. 5 times 10 is 50, plus 2 more gives us 70. And I'm going to put that decimal point here at the end. And now, because I need to put my decimal point back in, I'm going to do the inverse, or the opposite of what I did to get there. So since I'd multiplied by 10 to the first, I'm going to divide by 10 to the first, or move my decimal point back one spot, which would give us just 7.0, or just 7 for our final answer. So let's look at what happens when you're multiplying by more than one decimal. We're going to start the same way. So I'm going to take my 1 and 23/100. I'm going to multiply it by 10 to the second power, because that's going to move my decimal point over two spots, giving me 123. And I'm going to put my decimal point at the end. 1 and 4/10, just like we did above, we're going to multiply it by 10 to the first, which is going to give us 14, decimal point at the end. Now I've mathematically moved my decimal points out of the way. I'm going to multiply just like I would normally with whole numbers. 4 times 3 is 12, and carry the 1. 4 times 20 is 80, plus 1, or a group of 10, right, is 90. And then 4 times 100 is 400. I add in that 0 placeholder there. I can do 10 times 3, which is 30. and then I have 10 times 20, which gives us 200. And then I have 10 times 100, which gives us 1,000, or that 1 in that place value. I go ahead and add, so I have 2, 9 plus 3 is 12, 4 plus 2 is 6, plus 1 is 7, and then here. So now I have 1,722 as my answer when I'm multiplying my whole numbers. Oops. So now I have to think about everything I did. Oops. Here. So since in total I had multiplied by 10 to the third because I had a 10 squared here and a 10 to the first here, when I go backwards, I'm going to divide by the total, or 10 to the third. Now you could do it twice, but I like to just make it one step if I can. 10 to the third means I'm going to move my decimal point back 3 spots. So in the end, my answer is 1 and 722 thousandths. Now we can also use multiplication to think about, does our answer make, or estimation to think about, does my answer make sense? Like in our first one, I had 1.4, 1 4/10 times 5. Even if I ignore the 4, 1 times 5 is 5, so my answer should be around 5. So 7 seems like it would be reasonable because it's a one-digit answer. Here, 1 and 2300ths is around 1, 1 and 4/10 is around 1, 1 times 1 is 1, so my answer should be close to 1. So the 1 and 722 thousandths seems reasonable. So like I said, we're just simply moving our decimal point out of the way because mathematically it's a strategy that we can use. I'm just following like what we did before with our powers of 10. So I'm going to take 1 and 4/10, I'm going to multiply it by 10 to the first to get a whole number, and then I'm just going to do the inverse. Here, since I had two numbers that were decimals, I multiplied each of them by their own power of 10 to create whole numbers, but when I divided, I could put those two together, so 10 to the second plus 10 to the first gave me 10 to the third, which meant I moved my decimal point back 3 spots, which gave me my final answer of 1 and 722 thousandths.